All right, everybody, welcome to the video here for the review of unit number 4. So what I'm going to do here is just kind of go through these quickly. If you need to pause the video or rewind the video, you totally can. So for this first one, if you read through this, you saw that it gave us this like crazy looking equation, but whenever we're determining the minimum height of something, when it's a sine or cosine function, we only care about two values, the midpoint or the midline and the amplitude. So the amplitude is 70 and the midline or the halfway point of this function is 80. So what that means is this function is going to oscillate by 70 above 80 and below 80. So if we wanted to find the maximum, it would be 150, but we want the minimum. The minimum would be 10. That would be the difference between these two. So if I start at 80 and go down 70, I would be at 10. For number 2, it says a circle centered at the origin has a radius of 10. So if we have a circle centered at the radius of 10, we have this picture. The reason why I drew the radius in quadrant 2 is it told us the angle that creates it is in quadrant 2. It then says the y-coordinate is 8. So if I drop down a vertical line here, that vertical line's distance is going to be 8. And it wants us to know the value of cosine. Well, that's a big kind of help because we know in quadrant 2, sine is positive, meaning cosine is negative. I already know it's not C and it's not D. Now to find the missing side here, we have to use Pythagorean theorem. So I'm going to say a squared plus 8 squared equals 10 squared. And if I do some quick calculating, I can see that a squared equals 36 or a equals 6. And if we want to find the cosine ratio for this angle, it would be the adjacent side, which is 6, over the hypotenuse side of 10, but since it's in quadrant 2, negative, which gives us choice A. Number 3 is using this identity, the Pythagorean identity we did in lesson 7. I will be 100% honest with you. I was really nice and did not put one of these on your test. However, it is a good skill to kind of practice. So what we're doing here is we're plugging in negative 0.7 for cosine, meaning we don't know sine. And we're just going to use some algebra here to solve, just like we did in lesson number 7. If I do some subtraction here, I get sine squared of theta equals 0.51. Since we are in quadrant 2, we know sine is positive, so when I square root this, I'm going to get the positive square root of 0.51. Now to find tangent, we have to remember tangent is the ratio of sine divided by cosine. So the sine we just found is the square root of 0.51. The cosine they told us was negative 0.7. So the tangent value rounded to the nearest hundredth is going to be negative, and whatever the heck that number comes out to be. I'm good at mental math, but not that good. 0.51 divided by 0.7, so we get 1.02. For number 4, it tells us that we have an angle in standard position. As soon as we see standard position and the words unit circle, we're thinking any point is the coordinate of cosine, comma, sine. So I already know the cosine and I already know the sine of this function. It says, what is the value of secant? Well, there are 3 reciprocal functions. Secant is the reciprocal of cosine. So if we know cosine, which we do, cosine is negative 1/3. To find the secant, I just take the reciprocal, which would be negative 3/1. There you go, choice A. Just to quickly go over the other reciprocals, cosecant is the reciprocal of sine, and cotangent is the reciprocal of tan. You should know all 3 of those for your test for unit 4. Number 5 tells us we have an angle in standard position, and it tells us that it passes through this point. Notice that this does not say unit circle. So that x value is not the cosine, the y value is not the sine. We're going to have to find those values. Now, because they do give us the point, and that point is in quadrant 4, I can draw my triangle in quadrant 4, and I know this point is the coordinate 2, -1. So the x value is 2 and the y value is 1. And then that can allow me to find the missing side. So we wind up getting 5 equals c squared, or the square root of 5 equals c. So this hypotenuse is the square root of 5. Now we want to find the exact value of sine. So we're going to say the sine of theta in quadrant 4 is negative, and it's the hypotenuse, the opposite divided by the hypotenuse, so 1 over square root of 5. Which is a good answer, but not the exact answer. We want to simplify by getting rid of that square root. We don't like that square root there. So if we do that quick little rationalization that we learned how to do back in the beginning of this chapter, we wind up getting negative square roots of 5 over 5. All right, moving right along. To change something from radians, we have to put it into degrees. We multiply it by 180 over pi. That's the ratio. I'm going to give you the ratios. You're just going to have to know when to use which one. So if we do 11/6 times 180, we get 330 degrees. Notice that's not a choice. So we have to figure out which choice is coterminal or terminates at the same place as 330. So if we add 330 to 360, you get 690, which is not a choice. If you add again, it's just going to keep getting bigger. So instead of adding a full circle, let's subtract a full circle. So if I do 330 minus 360, I'm left with negative 30, which is the answer we want. That's the choice there. All of the other ones will terminate in a different location. Number 7 says, what is the measurement of the angle 8 pi over 5? So again, we're just converting. This time we just need to know the angle. We don't have to worry about what's coterminal here. The pi's are going to cancel, and you're going to get whatever the heck that comes out to be. I think it's 288, but let me check that. I'm not confident. Okay, 36 times 8, I believe, is 8/5 times 180. Yeah, 288. For number 8, we're converting from degrees to radians this time. So when we do this conversion, we're going to take the 235, and this time we're going to multiply it by pi over 180. Again, knowing which conversion to use when. So if I do this, I'm going to get 235 pi over 180. Now we just have to reduce this fraction. Now if you type it in with pi, it's going to give you some crazy decimal. We don't want that crazy decimal. We want to simplify 235 over 180. So essentially, just plug the fraction without pi in your calculator, right, and hit math, enter, enter. If you do that, you're going to get 47 over 36. So we're going to get 47 pi over 36 for my final answer for that one. Number 9. Number 9 is a cosine function. So as soon as I see it's a cosine function, I am instantly going to cross off B and D. Choice A is a positive cosine function. Choice C is a negative cosine function. So both are cosines. It then says has an amplitude of 2. So from the middle of the graph to the top of the graph is 2. A works. From the middle of the graph to the top of the graph is 2. C works. So far everything about these two graphs is the same. It then says that it has a period of 2 pi over 3. This is for one cycle. So on my graph, if I look at just one cycle of the cosine curve, which one seems to have a period of 2 pi over 3? Well, even though you can't really determine it from C, even though you can, but you can't, I know the answer is C because if you look at A, 2 pi over 3 is way over here. That would take 3 cycles to get there. So the period is going to be different than 2 pi over 3 for sure. So by process of elimination, C is your answer. Number 10 gives us this function. It looks like a sine curve, right? Look at the middle of the graph. Here is the middle of the graph. We're starting at the middle, going to the top, going back to the middle. That's a sine curve. So right away, it's not choice A, and it's not choice B. Now, what is that middle value? What value is there? So the k value here is 9. The a value is from 9 up to 10, 12, 14. So from 9 to 14 is 5. So which function has an a value of 5 and a k value of 9, which also represents a sine function, is D. Notice we didn't really care what the period and stuff was because they all have the same b value. If we wanted to practice just for funsies, we can say, well, this graph starts here at 0. One cycle takes 12 to happen, so the period is 12. If I wanted to find the frequency, guess what I'm going to get? You guessed it, pi over 6. That's what's in all of my functions. Look at us, we're grooving right through this, right? Let's take a look at the next one. So the next one gives us this cosine curve, right? Look at just one cycle. Here's one cycle of this cosine curve. Notice it takes pi to happen. So the period is pi. Well, if that's the case, we can find the frequency, divide by pi, and the frequency is 2. Why do I care about the frequency? I noticed that a lot of my choices had different frequency values. So B does not have a frequency of 2, nor does C, nor does D. The only one that does is A. Remember, frequency is B. It's the number that's next to X. Alrighty, moving right along. 12 gives us a radian measurement, and it wants us to draw it in standard position with its reference angle. So 13 pi over 20, if I convert that by multiplying by 180 over pi, these pi's cancel, and you get, I don't know what you get there, 9 times 13 times. You get like 117-ish, which is a quadrant 2 angle. Notice all of the terminating rays are in quadrant 2. But B goes in the opposite direction. This would be a negative rotation. So B is no good. But if you look, all the other ones, A, C, and D, all kind of have the same alpha angle. The difference here is what's theta. Theta is the reference angle. The reference angle is the angle that gets you back to the x-axis in that quadrant. So C doesn't make sense. This angle goes back to the y-axis. D is the answer because that's the angle that gets us back to the axis in the quadrant we're in. A is the distraction answer because it does get you back to the x-axis, just it's in the wrong quadrant. Right? We want to be in the quadrant that we want. Okay? We want to create an angle in quadrant 2. Alrighty. Number 13, which one has the greatest amplitude? So the two that I would look at would be B and D first because they're just the equations. Amplitude here is 3. D, the amplitude is 5. Remember, the amplitude is always positive. That negative in front there just flips the graph upside down. Now, for these two graphs, we have to figure out what's the bottom and what's the top and cut it in half. That's the amplitude. So 1, 2, 3. 3 to 7 is 4, so this amplitude is 2. This goes from -5 all the way up here to 3. From -5 to 3, that's 8. Half of that would be 4. So this amplitude is 4. The biggest one is D. Right, showing that that graph is going to vary the most. All right. Which of these is 1 radian? 1 radian converted to degrees is 180 over pi. If I plug that into my calculator, I got about 57 degrees. Which angle represents 57 degrees? Well, that would be A, because that's definitely 90 degrees. This is like 180 degrees, and D is 360 degrees. So the only one that's a quadrant 1 angle is A. That's an easy one. We should all get that one right. Number 15, describe the period of the graph. So to make one cycle, it takes 2/3 of a second. What does it represent in the context? Well, that would be the time it takes for the tire to complete a full rotation. That's it. That's all I asked you to do. And last but not least, the graph. So it tells us it's a cosine function. Cosine functions start at the max, go back to the max. Amplitude is 3. Midline is -1, so we know the max and min. So the max is going to be 2. The min is going to be -4. I'm starting at -1, going up 3 and down 3. So I want to graph that. So I'm going to put -1. I'm going to put +2 and down 3 from there. And I'll be at -4. It also tells us the period. Well, the period is going to help us a lot for the graph. So the period is pi over 2. Got 4 boxes and put the period. If we then follow the pattern for cosine, which goes maximum, midline, minimum, midline, maximum, we've now just created our one cycle. It didn't ask me to, but I will tell you this on your test when I ask you to graph. It's then going to say, write the equation of this function. So why don't we practice? So this function is y equals 3 cosine of something minus 1. That something is the b value. Well, to determine the b value, we're going to take our period, multiply it by the frequency and set it equal to 2 pi, do some fun algebra, and see that the frequency is 4, so I'll toss a 4x in there, and there is your equation. That is something you will have to do for your test on next week. And that's it, right? All right. So hopefully that made sense to you. If not, you can always rewatch the video, look back, or reach out to me with questions, and I will see you all soon.